The cancellation property basically says that you can cancel out things if you have an equation involving elements of a group. Let me show you what I mean. The equation G star A equals G star B implies or leads to A equals B. Similarly, the equation A star G equals B star G also implies that A equals B. And here's the bit where people make a mistake. Don't get confused. You see what's common about those two equations I wrote down? In the first case, the g's are both on the left. In the second equation, the g's are both on the right. But you're not allowed to mix them up. For example, the equation G star A equals B star G doesn't imply A equals B. You can't start off with that equation in a group and without any further knowledge deduce that A equals B, because it's actually not true in a lot of groups. Okay, the proof is really easy. You sort of think analogously to just normal equations with numbers. If I told you that G times A equals G times B, how would you get that A equals B? You would divide both sides by G. You see in that first equation, G star A equals G star B, you want to sort of divide both sides by G. We don't really have a notion of division. But what we do have is we have a binary operation and we have inverses. So multiplying by the inverse is what we'd like to do. Okay, so you think, what can you do to both sides of this equation? What I'm going to do is I'm going to multiply both sides by G inverse. But you have to be very careful about how you do it. In group theory, when you say you're going to multiply both sides by G inverse, you always say I'm going to do it on the left, or you say you're going to do it on the right. You see, I stuck the G inverse on the left of both expressions. I could also stick it on the right of both expressions, but I can't mix and match. I can't put it on the left of one side and on the right of the other. Okay. So you have to be careful. Okay, and then we just go through some basic steps to try and reduce this. The first thing I do is I use associativity to say, well, I don't have to work out the G star A first, I'll work out the G inverse star G. And the reason I want to do that is because, well, it just gives me the identity star A equals the identity star B. And of course, using the property of identity, this just gives me A equals B. And that's how you deduce it. So in some sense, I'm trying to say, yeah, you can cancel out G's, as long as they're sort of both on the same side. They have to be on the left of both sides of the equation, or on the right on both sides of the equation. And then I'm not going to do the other case, because I think if you understand one, you understand the other. The other case is practically the same. Okay, and I'm going to finish by telling you about the Sudoku property. So, which says this: in a Cayley table, each symbol or each element of the group appears exactly once in each row and column. Okay, I'm going to do a proof, which is actually by contradiction. I'm going to say, well, let's suppose you actually saw the same thing twice in one row. What if your Cayley table looked like this? So let's say, well, here's so this is supposed to be a Cayley table. All right. And I'm supposing that somewhere in my Cayley table, you see the same thing twice in a row. I'm going to tell you this can't happen. I'm going to tell you why. You look at those two squares and you think, well, what are the columns labelled by? I don't know, let me call them A and B. Why not? What's the row labelled by? It's labelled by G. If those two entries are equal, what we're saying is that G star A equals G star B. But by the cancellation property, this tells you that A equals B. So we've used that same trick again, right? You pretend there are two sort of different columns where you see these equal entries, but I've proved to you that the column labels are the same. They're actually the same column. So you couldn't actually see two different entries in the same row that are equal. Because if you could, they had to be in the same column, so they can't be in different columns. Okay, well, that's sort of brief, but you can sort of have a think about that and try and get to the bottom of it. Okay, I just want to finish with one quick fact. And then maybe a joke. Okay. So given G and H, there are unique X and Y such that G star X equals H and Y star G equals H. Okay, so how would you find the X? Well, it's pretty easy, because you would try and move the G to the other side by hitting both sides with a G inverse. And that tells you precisely what X is. The other case is exactly the same, so you could do it for yourself. And I suggest that you do. Work out what Y has to be. So the moral of these last few facts that we've looked at is this. You can multiply both sides of an equation on the left or on the right. You have to do it consistently. Okay, and we'll finish there.